Hello dear students, today we will solve exercise question number 10, 11, 12 from Science and Technology part 1, chapter number 4, Effects of Electric Current. Question number 10. Name the following diagrams and explain the concept behind them. Observe the diagrams. Answer. First diagram. Fleming's right hand rule. The rule states that stretch the thumb, the index finger and the middle finger in such a way that they will be perpendicular to each other. In this position, the thumb indicates the direction of motion of the conductor, the index finger the direction of the magnetic field and the middle finger shows the direction of the induced current. Second diagram. Fleming's left hand rule. According to this rule, the left hand thumb, index finger and the middle finger are stretched so as to perpendicular to each other. If the index finger is in the direction of the magnetic field and the middle finger points in the direction of the current, then the direction of the thumb is the direction of the force on the conductor. Question number 11. Identify the figures and explain their use. A. Observe the given figure. Answer. A fuse. To be more specific, we can say that this figure is of cartridge fuse. They are cylindrical in shape and have a contact point at each end. A fuse is an electrical safety device that operates to provide overcurrent protection of an electrical circuit. Its essential component is a metal wire which is used as a precautionary measure. As soon as high current flows in a circuit, the fuse wire melts and breaks the circuit and any mishap is avoided. Fuse wire is made of a mixture of substances and has a specific melting point. It is connected in series to the electrical appliances. Many times, particularly in the summer season, huge electrical power is used in the evenings due to home lighting, fans, air conditioners, use of electricity in shops, etc. As a result, excessive current is drawn from the transformer supplying the electricity, and if the capacity of the transformer is insufficient, its fuse wire melts and supply gets shut down. Such events occur due to overloading. Observe the given figure B. Answer. Miniature circuit breakers, in short MCB switches. These days, MCB switches are used in homes. When the current in the circuit suddenly increases, this switch opens and current stops. Different types of MCBs are in use. Nowadays, MCB switches are used in a low voltage electrical network. For the entire house, however, the usual fuse wire is used. Identify the figure C. Answer. Direct current. In short, DC generator. A DC generator is a machine that converts mechanical energy into direct current electricity. The axle is rotated with the help of a machine from outside. When the armature coil of the generator rotates in the magnetic field, electrical potential difference is produced in the coil due to electromagnetic induction. This produces a current which can be measured by an ammeter as shown in the figure. The DC does not change the direction in the external circuit. To achieve this, a split ring is fixed on the axle. Because of this arrangement, the branch of the coil going upwards is always in contact with one brush and the branch going downwards is always in contact with the other brush. Hence, the current flows in one direction in the external circuit. Question number 12. Solve the following example. A. Heat energy is being produced in a resistance in a circuit at the rate of 100 watt. The current of 3 ampere is flowing in the circuit. What must be the value of the resistance? Solution. Given P is equal to electrical power is equal to 100 watt. I is equal to electric current is equal to 3 ampere. R is equal to resistance that we have to find here. Formula. P is equal to I square into R. Therefore, R is equal to P upon I square, which is equal to 100 watt upon 3 ampere bracket square, which is equal to 100 upon 9 equal to 11.11 ohm. Therefore, value of the resistance is equal to 11.11 ohm. B. Two tungsten bulbs of wattage 100 watt and 60 watt power work on 220 volt potential difference. If they are connected in parallel, how much current will flow in the main conductor? Solution given P1 is equal to 100 watt, P2 is equal to 60 watt, V is equal to 220 volt, I that we have to find here. Formula P is equal to V into I. Therefore, we can write I1 is equal to P1 upon V and I2 is equal to P2 upon V. Current in the main conductor I is equal to I1 plus I2 because given that connected in parallel. Therefore, P1 upon V plus P2 upon V is equal to P1 plus P2 upon V, which is equal to 100 watt plus 60 watt upon 220 volt, which is equal to 160 upon 220 ampere, which is equal to 0.7272, which we can take as 0.72 ampere. Therefore, current in the main conductor is equal to 0.72 ampere. C. Who will spend more electrical energy? 500 watt TV set in 30 minutes or 600 watt heater in 20 minutes? Solution given P1 is equal to 500 watt, P2 is equal to 600 watt, T1 is equal to 30 minutes, which is equal to 30 upon 60 hour is equal to 1 by 2 hour. T2 is equal to 20 minutes is equal to 20 upon 60 hour, which is equal to 1 by 3 hour. Here we have to find electrical energy used by both the appliances. Formula electrical energy used is equal to P into T. TV set P1 T1 is equal to 500 watt into 1 by 2 hour is equal to 250 watt hour. And for heater P2 T2, which is equal to 600 watt into 1 by 3 hour, which is equal to 200 watt hour. As 250 watt hour is greater than 200 watt hour, the TV set will spend more electrical energy than the heater. D. An electric iron of 1100 watt is operated for 2 hours daily. What will be the electrical consumption expenses for that in the month of April, given that the electrical company charges rupees 5 per unit of energy? Solution given P is equal to 1100 watt, T is equal to 2 hours daily into days of April are 30, so 30 is equal to 60 hours. Charges is equal to rupees 5 per unit of energy. To find expenses, remember when 1 kilowatt hour electrical energy is used, it is termed as 1 unit of energy. Formula number of units is equal to capital N is equal to PT watt hour, which is equal to P into T upon 1000 kilowatt hour, which is equal to 1100 into 60 upon 1000 kilowatt hour, which is equal to 66 units. Therefore, electrical consumption expenses is equal to number of units into charges equal to 66 units into rupees 5 per unit, which is equal to rupees 330. Therefore, electrical consumption expenses is equal to rupees 330. Write all these questions and answers in your notebook. Thank you.